All right, guys, so 3.6, we're talking about curve sketching. And the reason why we use the term sketching is obviously these aren't going to be exact graphs. Basically, what we're going to be given is a graph of a derivative. So we're going to be given, for example, down here, this is the derivative graph of f. So this is the graph of f prime. It's not the graph of f, it's f prime. And we're going to look at that graph and we're going to try and pull information from it and try to recreate a sketch of what f might look like, as well as what f double prime looks like. So quick rundown of kind of what you do. First, you're going to make a sign chart. And we don't always actually make the chart, but you're looking at the signs of the derivative, paying attention to the critical values, so where it equals 0, and where it's increasing or I guess where it's increasing or decreasing on our regular graph is going to be where it's greater than 0 or less than 0. So taking just that part A, if I'm looking at this graph right here. So the first thing I like to do right below the graph, I usually try to draw my sketch, just because I can look right here and transfer that information straight down. Like I know that this is the value of 2, this is 2, 4's over here, 4's over here. Now, if I look at this graph, the first thing I want to look at is where I cross 0, right here. Remember, these are my slopes, okay? These are all my slope values of my original graph. So right here at 1, I have a slope of 0. So my slope is going to be 0. And to the right of that, again, these are representing my slopes. So it's really hard to not get hung up on looking at the line itself as looking at the value. Okay, so if this was 1, then at x equals 2, I would have a slope of 1. I don't care what this slope is. All I know is that all of these numbers are positive and they're getting bigger. So to the right of 1, I'm increasing. And not only that, but my slope is getting bigger. So it's not going to be increasing this way, because that way my slope gets smaller. It's going to be increasing like this. So, and I don't know what this value is right at 0, but I also know to the left that my slope down here, this is negative. My slope down here is negative. So that means my function is decreasing. And as I go to the left, my negative numbers get bigger. So again, as I decrease to the left, it's going to be a little bit negative, but then my slope is going to get more and more negative as I come from the left to the right. I've got a really big slope, and then it gets lower and lower and lower. Okay. So my slope starts out super negative, and then it kind of flattens out to be just a little bit negative. And then I know right at 0, that's going to change. I don't know. And here's where, again, we call this a sketch. We don't know where this is happening. All I know is that on my graph somewhere, right here at 0 or at 1, I have a slope of 0. And this side, my slope is positive, so my graph is going up. On this side, my slope is negative, right? My slope is negative, so my graph is going down until it reaches that point. So we'll call this our f of x. Okay. So that's kind of what A is looking like. And I know we don't quite have a sketch all the way yet, but part B says, examine the sign chart. You can determine where it's increasing or decreasing, as well as relative minimum and maximum. Well, we already did that. We said, well, it's decreasing over here, increasing over here, and it has a slope of 0. If you're a chart kind of person, then you can make a chart of this graph and do the numbers and the positive and negatives, whatever works for you. Okay. Part C says, then you make a chart for f double prime. So our second derivative of x, which is the derivative of f of prime of x. You're interested in the intervals where the slopes are positive and negative. So underneath this one, and I know some people do this backwards. Some people like to do the second derivative first. And really, I think sometimes it just helps if they're in order. So I'm going to ignore this blue graph for just a minute, and I'm going to go back up to my original graph. I'm going to erase some of this information right here. So looking up at this original graph, now when I take the derivative of this function, look at my slope. That's all I'm interested in. This is just a straight line. So my slope stays the same the entire time. And it's a positive slope. So I'm going to be above, if this is f double prime, I'm going to be above 0 because my slope is above. And if I look at this right here, it looks like I'm going up 1 and over about 2. So my rise over run looks like it's what, maybe up a half and over, or it looks like I'm going twice as far as I'm going up is what I mean. So I'm going half up and over 1. So my slope, I would say that, this is maybe 1/2. And because my slope doesn't change, my second derivative graph is just going to be a straight line. Because at all of these points, my slope is exactly the same. It never changes. Okay? So that would be my second derivative. And again, because if you remember your rules, if my second derivative is greater than 0, that means my function is concave up. So looking at my picture that I started to draw, it's concave up the whole time. So it looks kind of like a parabola. I don't know where it's going to be up and down, but I do know that it's going to be centered right here at 1 because that's where it crosses. I know that's my minimum. So I at least know that it's going to be centered there. Okay. Now looking at this next one, I wish, in fact, maybe, I don't know if we have enough room to do that. Again, sometimes it helps to have your original function on top and then work your way down. But let's go ahead and do our original function first, and we'll just get some information. So I've got like -1, -2, -3, and then we've got 1, 2, 3. So this is f of x. So again, first thing I look at, where does my slope equal 0? And again, remember these values are and in fact, sometimes right here on the y-axis, if you write slope, you can remember right here, my slope is 0. That's all I know. I don't know where it is. I just know that my slope is 0 at that point. And right here, my slope is 0. Okay? So at those 2 points, something's going to happen. I'm going to be either going up and then down, or something's going to be going on. So if I look to the left of this point, all of these values are negative, which tells me that my function is going to be decreasing until I get to 0. Then after 0, my values are still negative all the way until I get clear over here to, what is that, 4? So my function is decreasing this entire time, and it doesn't happen until I get to 4 before I finally start increasing. So right here, I start increasing, which means I'm going down, 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 and then back up at this point. So that is going to be a minimum. So I'm going to put it, I kind of like to put my minimums low. So I'm going to put that minimum down here. And I know over here, I'm increasing. All right. On this side, I'm decreasing. And I know right here, I kind of level out. It flattens out. But I also have these weird points. Right here is an interesting one. And this is where kind of it wants you to not just look at the first derivative, but it wants you to look at the second derivative. Because if I were to draw my second derivative, so if I were, let's do that one in black, if I were to draw my second derivative, remember my second derivative is the slopes of my first derivative. So right here, my slopes are positive until I get to -2. At -2, so my slopes are positive and they're steep, and then they kind of flatten out. So my slopes are, my slopes are negative down here. And then at this point, my slopes all of a sudden become, or my slopes are positive and then they become negative. See, it's a lot to wrap your head around. So I've got positive slopes. And then at this point, I cross. And then from there, my slopes are negative until I get to 2. So at 2, my slopes, I'm negative, 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 negative. But if you notice right here at about, where's it going to happen for us? Right here at about 0, I'm concave down. And then all of a sudden it concaves up. So my slope is getting steeper and then it's getting less steep. So right here, I kind of change directions. Right there, I'm going down and then I switch and I start going up. And then when I get to 2, my slope is 0. So that matches. And I start going up, and I'm going up a whole bunch, right? And so this is my second derivative. Remember, my second derivative tells me concavity. So right here, I'm concave up, concave up. Right here, I'm concave down. Is what my derivative, if my derivative is less than 0, that means my function is concave down. So I'm concave up until I hit this point. And then I'm concave down until I hit this point right here. And then I'm concave up again. So concave up looks like this, right? And then concave down means I'm kind of going downwards like this. And then concave up means I'm going this way. And then from there, I know I go back up. So my function, it looks like I've kind of got like part of a parabola, and then it flips over and it starts going down. And then it starts kind of going at 2 right here. It starts concaving back up, and then I go up again. All right. So a lot going on here, guys. And I promise you, this is one of those. I really like the problems with Delta Math where you get to keep trying more and more examples of these, because they're not, I mean, if you look at this one kind of looks like x squared graph, right? Well, the derivative of an x, or I guess we're going backwards. So before x squared would be x cubed. And that kind of looks like an x cubed graph a little bit, which means that this one right here, our original function would be some kind of x to the 4th mess of some sort. I don't know exactly what it looks like, but we know what it kind of looks like. So let's try a few more. Again, it's one of those that we're just going to have to keep practicing and practicing to get better. So here is my f prime. So let's start with, and again, if you want to do the second derivative, actually, maybe we'll do that first this time. Let's do f double prime first. So I've got this point -2 that seems important because my slope, remember, f double prime looks at the slopes of f prime. So my slope is negative. So that means my values are going to be down here. My slope is negative, and as I approach 2, my slope is getting steeper and steeper and steeper, and then it's getting really steep right as I'm getting to -2. So that means right here it's negative, but it's not very high negative. And then as I approach -2, maybe we should draw this in blue. So I know I'm negative, and then as I approach -2, I'm getting steeper. Okay, so that's kind of what that part would look like. And then right at -2, I've got a cusp, which means there's going to be like a vertical asymptote or something going on right there. I don't know. but I can't do anything right at 2. But just to the right of 2, now my slope is positive. So my function is going to be up here. My second derivative, my values are positive values. And it starts out really steep and then it kind of flattens out, but it stays positive. So it starts really high up here and then it kind of flattens out and stays, but it stays positive. Okay. And this is where some of you might like the table. You might like to, it might help you see the slopes as slopes. Because it really can get confusing going from, well, these are values, but they're values of the slope of the previous graph. So when I'm looking to make my second derivative, I'm not looking at the value right here. This is 1, 2. I'm looking at the slope right there. And the slope isn't very big. The slope is like 1. So my y value would be at 1. My y value would be like 1. And as I go to the right, at 2, my slope gets a little bit lower. So as I go to the right, my y value gets lower because my slope is lower. And that's where I'm getting my y value. Now my actual function, and I wish I would have left ourselves a little bit more room for this one, but we'll try and make it work. So my actual function, let's look at what's happening with all of this information put together. So here's that -2. Here's 1. Here's -1. I don't know if those matter. But remember, this is my original function. So the slopes of this function are right here. These are my slopes. So what that means is at 0, my slope is this value, 1.5. And as I go to the right, my derivative, my f prime is positive, which means that my function is increasing. So starting right here at -2, my function is increasing. And my slope, again, the slope this value right here is small. So as I go to the right, my values get bigger. So that means that my slope was getting bigger as I went to the right. So something's happening like this. Okay. My slope is getting steeper as I go to the right. So it's curving up. It's a little bit exponential. And then to the left, my slope is still positive, but my slope is really big right here. My slope of my original function is 2. And as I come to the right, the slope is flattening out. It's getting lower and lower because my y values are getting lower. And that's so, again, remember, these represent the slope. So as I go to the right, I'm not looking at the slope of this line. I'm looking at the values. My values are getting lower, which means my function is getting flatter. It's not as steep. So it started out really steep. And then as I get close to 2, it kind of flattens out. And I'm not sure what happens at 2, but I know something's going on because I don't know, maybe there's a hole in the graph. Something weird's going on right there at 2, but my function is increasing. And then if I compare it to my second derivative, remember my second derivative, if f double prime of x is less than 0, so this negative right here means I'm concave down, which is what I've got right here. It's concave down. And up here, I'm concave up because I'm above 0, right? Does your head hurt yet? Mine does, and I'm the one doing this. Okay, so let's just keep going with examples. Again, this is f prime. So I'm going to go ahead and I don't know, what should we do? F double prime again. Some of you might like doing it that way. So to go from here to here, I'm taking the slopes of this function and graphing them down here, okay? So right here, something happens. My slope doesn't exist. I get this asymptote because my slope doesn't have a value right there. So something's happening at that point. But I know that my slope, as I get closer and closer to this value 1, look at my slope. It's positive, but it's getting lower and lower and lower and low. My slope is getting steeper. I guess it's in the negative direction, right? So my slope is negative of this graph. We're going to double prime, not to the original function. So the slope of this graph is negative, and it's getting steeper and steeper and steeper as I go to the right. So as I go to the right of this one, my slope is going to be getting more and more and more negative. And then at this point, I get that asymptote. And then I have a really, really steep, I'm still negative, right? But I'm really steep negative. And as I go to the right, I kind of flatten out. My slope flattens out. So I go from being really steep, and then I start to flatten out. Now, maybe I shouldn't draw the rest of that line, because I don't know I don't know what's going to happen over here, but I don't see my function going up. So I kind of feel like my function, my slope, stays underneath that x-axis the whole time, okay? So now if we draw, let's try and take that information, because this negative right here tells me that my function is concave down. This tells me that my function is concave down. This value of 0 tells me that that's a critical point, right? And to the left, I have a positive slope because my values are positive. And to the right, I have a negative slope because my values are negative. So that gives me, and maybe I should be writing this in a different color, okay? So all of this red. So this graph tells me, I'm going to write in blue what I know about my original function. This tells me that my original function is concave down, because this function is less than 0. My double prime is less than 0. It's still less than 0, so it tells me that this is also concave down. All right. Then when I look at this point, that tells me that that's a critical value. So that could be a maximum or a minimum. So when I look to the left, all these values are above the axis, which means my slopes are positive, which means I'm increasing on my normal function. And over here, my slopes, because I'm below the x-axis, my slopes are negative, so I am decreasing on my function. So if I draw my function, and I'm going to draw it right here. This is just, okay, we'll draw it down below. Here's my x-axis. We care about 1 because something's happening at 1. Well, because I'm increasing over here, so I'm increasing on my graph, and then right here I get a maximum because this side I'm decreasing. So right here at 1, I have a maximum. And I know that it's concave down to the left, and I know it's concave down to the right. So really, I just have like an upside down parabola of some sort. I don't know where it is. It could be clear down here. But I know that its maximum is at 1, and I know that it's concave down the whole way because these values are all less than 0. And I know that it's a maximum because I go from increasing to decreasing. Again, is it hurting? I hope so. This stuff gets kind of fun. The first ones, again, the more you practice, the better that you're going to get. And these, they don't even give you a graph. All these ones tell you is information. So they tell me that f of 1 is negative 1. So I know that at 1, I've got a point negative 1. Okay. It tells me, I'm kind of working backwards. It tells me that my second derivative is greater than 0. And it looks like that is implying everywhere. So that means if I'm greater than 0, that means I'm concave up always. It tells me that my derivative at 1 is 0. So at this point, my derivative is 0. So that's going to be a minimum or a maximum. But if I know that it's concave up, then we know that that's going to be a maximum of some sort. What else does it tell us? F prime of x is greater than 0 when x is greater than 1. So my slope, I'm increasing, and f prime of x is less than 0. So that just means I'm decreasing, right? So I'm decreasing, I hit 1, I get to my minimum, and then I start increasing. So I've just got a parabola. This one, it tells me that f of 2 is 1. So f of 2, I plug in 2, I get a 1. And it tells me my second derivative is greater than 0 when x is greater than 2. So that means I'm concave up after 2. My graph is concave up. I don't know if it's increasing or decreasing, so maybe I shouldn't draw it that way yet, but I know that it's concave up. All right. What else do we know? F prime of x is 0 at 2. So that means this could be a minimum or a maximum. And then it says that f prime of x is greater than 0 when x is greater than 2. So again, I'm increasing. When x is greater than 2, my derivative is greater than 0. Okay. What am I missing here? This one right here. I read x equals 2. F prime of x is equal to 0 when x is less than or equal to negative 2. So not only is this a flat horizontal point, but whenever x is less than 2, my slope is 0. So I've got some sort of line that goes straight across, and then at 2, all of a sudden it peaks. It starts turning into an exponential function. It's concave up, and it's increasing.